Hello and assalamu alaikum everyone. And after 105 question, we've got 106 question in the strength of material of by Andrew Patel, 4th edition. And in 106 question, they're asking the homogeneous bar shown in figure P106. This is P106 figure is supported by a smooth pin at C. This is your pin at C, and a cable that runs from A to B around the smooth peg at D. So this is the cable that runs from A to B that is supported by D. So the question is, find the stress in the cable. A diameter is given. If the diameter is 0.6 inches and weight of the bar is 6,000 pounds. Now, going towards the question, and this is problem 106, normal stresses. So the given data is diameter of the cable, that is 0.6 inches, weight of the bar, that is 6,000 pounds, and what is required is stress in the cable. Now this is your free body diagram. You have to learn it, you have to make it for every question. This is important. Now this is your pin, okay? It cannot support moment. 6,000 pounds is the weight of the bar that is acting downward, and you've got two reactions, that is at B and at A. The B is pretty easy, it's straightly upward, and the A is actually inclined, so we need to find out our vertical component for it. So if you want to find out vertical component, they have done it, but I will do it for you here. This is, for example, your diagram. Sorry, come on. Okay, this is your 3 and this is your 5. This is given in the question. If you want to verify it, see, this is your 3 feet, this is your 5 feet, and total is 10 feet. Got it? Now if you want to find out that actually this is your T. See, this is your T. Now this side is we need to calculate this side first, and that can be done by Pythagoras theorem, which says that hypotenuse squared is equals to perpendicular squared plus base squared. So is there any square? Yes, plus, then we have plus, which is 5 squared, that is equals to 34, and taking under root of 34 is your 5.8, which is under root 34. Pretty easy, you can write this is your under root 34. Sorry for that. Got it? Now let me write it for you here. That is under root 34. Just making some mess. And your this component is 3 divided by under root 34. That one is pretty easy. Now how to solve it? You need to take moment at C to find out the value of T. You know that moment at C equals to 0, and which is equals to 5 moment arm into T, the force, okay, plus 5, the total 5, into 3 divided by under root 34. This is your 3 divided by under root 34 into T. This is your 5 into T plus total length, that is 10, into 3 divided by root 34 into T should be equals to 5 into 6,000 pounds. So these both sides should be equal, and when you solve it, you will get your this answer, that is T equals to 2957.13 pounds. I could have done it, I can do it on the scientific calculator, but I cannot do it on this calculator. So if you have any problem, you can ask me. I will make a separate video for you on how to calculate it. It's pretty easy, it's pretty basic. You should have know, you should know how to calculate things at this level. Now you know that T is equals to stress into area, or stress is equals to load by area. You can pretty easily get it, which is equals to 2957.13 that we've got here, equals to stress into area. So area is, you have your diameter, pi r square or pi d square by 4 is your formula for air, and you will get your stress this way. This is in psi. So this is your answer for this question. If you have any queries, any problem, please ask in comment. I'll be really glad to answer your questions. That's it for today, and bye bye for now.